Okay, here is a question of the question 2. Let S be the region bounded by the graph of the polar curve of this function, and for there, the theta is bigger or equal than 0 and small or equal than the square root of the pi, as shown in the figure above. Find the area of S. If we want to find the area, we can use the integral, the 1/2 of the integral of the r theta square from 0 to square root of pi, and give a bracelet of this, and the d theta, and this is the S of the area of this place, area of the S, and then we put it into our calculator, then we get the answer. Here's our calculator. We go to the polar and go to the calculator, and we put the function into here. Let's just put the 1/2 first. 1/2 multiply with the integral from 0 to the square root no, put the pi first, the square root of the pi, and put our r theta into here. 3 multiply with square root of theta, and multiply with sine theta square. And also we needed to put this thing into square, and give a left bracelet and a right bracelet, and put it into a square, and d theta, and we put enter. We got our answer as 9/8 multiplied with pi, and we want to approximately 3.534297174. So this is the answer. Then we put it into our page. According to our calculator, we can find is 3.534. Yeah, 3.534. So this is the kind of thing. So we can solve the first question. Let's go to question B. The question B said, what is the average distance from the origin to a point on a polar curve that r theta equal to this thing for the theta that's over the 0 and the square root of pi. So if we want the average distance of point, the origin to a point, a polar curve, we need to know the whole length. Then the whole length is equal to integral of 0 to square root of pi and r theta d theta, and this is the whole length, and we divided it by the curve goals. So that's divided by this, means multiply 1/0 plus square root of pi. So if we put this into our calculator, we'll find our answer. Okay, here's our calculator. Now we just to modify it a little bit, modify our previous one a little bit, and we change this into a square root of pi. Didn't make it pi, square root of pi, and this we didn't change. Then we delete this two thing. Yeah, so we got the new function. We got a new function to calculate our average length. So we use this to get our approximation is 1.5799. So if we keep the 3 significant digits, it will be 1.58. Hence our answer is 1.5799. So this will be 1.580. So this is the answer. The approximately to 1.580, the average distance. Okay, here is our question 3. There is a line through the origin with positive slope m that divided the region S into 2 regions with equal area. Write but not solve an equation with one or more integral whose solution gives the value of m. So the solution give the value m. That means here is a line. Yeah, so that's how a line. So the value in here, is it's a 0 to some point. I think I can set it with x. So this from this place 0 to x, and change this thing into two equal sides. It's basic like that, like this. And if I want to find this thing, we can just basically think about the thing. First thing, I'm gonna make an integral like this. So this integral from 0 to x of 1 over 2, 0 to x r the theta of square, r theta square of d theta that will equal to this area, half of this area. So we'll copy this down and put it here, and equal to half of the whole area. And this thing multiply 1/2 again, and multiply 1 over 2, multiply with 1 over 2 again. So now the x is the value of the radius as a degree in terms of degree, but it's said we need a thing that's solved for m. So we know the tangent x. The tangent x is equal to the slope of the m. So we can see the arctangent of the m is equal to x. So we can put this thing into our function, and we can copy this thing, and our final solution in here will change into another one. Yeah, we'll put this arctangent m into here and copy. Put our arctangent m here and make it smaller, so or else it will too big. Yes, and put this thing a little bit left and make it prettier, and make this thing. So delete them first, and we can take out the bracelet. So 1 over 2 multiplied with 1 over 2, that will equal to 1/4. Yeah, 1/4 of the integral in here. So that will equal to each other, and put this thing a little bit left. Yeah, so this thing will equal to the left side. Yeah, so this thing can solve for m. Arctangent of m equal 1/2 of this thing. This is the area of the half, equal to half of the whole area. We can find the m in this integral. The final question said, for k bigger than 0, let AK be the area of the portion of the region S. So that means that's a part of the region S, and it's also inside of the circle R equal to the k cosine of theta. So let's see the R of k cosine of theta finds the limitation of the k approach to the infinity and the AK. So if we draw a circle of R equal to k cosine of theta, it will just look like this one, and put it here. So we can see if this k grows to bigger, this circle will bigger and bigger. Note in here. Let me put it back. I'm gonna just zoom out of the paper, but I just accidentally zoom out of this one, and zoom out of the paper. Okay, so we can see this. Put it here. Yeah, so we can see that as the circle goes bigger, it's also bigger than my paper, right? It's also bigger than paper. If that's big enough, you can image. The thing will include the area of the S, but then it will never include a part like this part. It will include this part, but never in this part, right? So let's go to this part, will never be. So we can think about this thing will just go to from 0 to half of the pi. It will go to the area of the AK, So we can just at the beginning, begin from here, end from here. Begin from here, end from the end to here. So the place is half of the pi, So we can write a equation like this. Limitation as k approach to infinity of the ak will equal to the 1/2 of the area, 1/2 the integral 0 to half of the pi of theta of r theta square d theta, and this is also equal to 1/2 of the integral 0 to half of the pi. And we can copy this thing down. We copy our function. 3. Sorry for my writing. I need to copy it down. 3 multiply with square root of theta, and multiply with sine theta square of squared d theta. Then we put this equation into our calculator. We find all the answer in our graph calculator. Okay, let's come back to our graph calculator and we can use the first one, right? So we can use the first one to modify it a little bit, especially here. We can change the from 0 to half of the pi. First the pi and the half of the pi. So we enter, and we got this, and then we'll find it's 3.3244. So we can put this answer in our question answer book. So now I can put the answer into our question answer book. It will be 3.324. 3.324. This is the answer. And this is an English version of the question 2. I wish you enjoy it, and see you next time.